All right, electricity class. We are going to go over the parallel circuit rules and how to figure out the values of the different characteristics in that parallel circuit. So first thing I want to do is just show you the circuit we're going to do real quick. So we're going to start putting our values in these charts, and I have a spreadsheet that I want you to do this with. So I want you to put the values that we are on this video in that spreadsheet, and then I have another practice video that I want you to watch after this and put the values for that in that spreadsheet, just like we did for this for the series circuit. Anyway, so we're going to go ahead. We have 9 volts at our total, so there's 9 volts. You gotta be careful of the order of some of these. I try to keep them consistent, but some of them are not exactly right. But 90 ohms at our first resistor, 45 ohms at our second resistor, and 180 ohms at our last resistor. Okay, so that's our setup. Now, notice that we have 3 paths for electricity. That's what makes it parallel. And we only have 1 resistor. Each one of these paths is a different branch. And there can be more than 1 resistor in there. When you have more than 1 resistor in there, it makes it more complicated. For right now, we're just doing a straight parallel circuit with 1 resistor per branch. That makes this relatively easy. We'll get into the other parts later, but just remember that there can be more than 1 resistor in there, and then when we read our first rule, you'll understand what I'm talking about here, why it makes it more hard or harder. The voltage, so the first rule is the voltage drop across any branch of a parallel circuit is the same as the applied voltage. Well, this is our applied voltage, and we know the voltage going through this branch from here to here is going to be 9 volts, because that's what our rule says. So if we put another resistor in there, that 9 volts would be divided between those 2 resistors. If we put 3 in there, that 9 volts would be divided somehow, not necessarily evenly, among those 3 resistors. So when there's only 1 resistor, you know it has to take all 9 volts because the rule is, again, that the voltage drop across any branch is the same as the applied voltage. So I know now that my voltage in this branch is 9 volts. And since I only have 1 resistor, resistor 1, the voltage drop on that is 9 volts. Same for resistor 2, only 1 there, 9 volts. Same for resistor 3. Makes it really easy. We'll get into how you figure it out if there's more than 1 another time. So now we know we have 2 variables in all at the 3 resistors. That means we can figure out something else. At all 3 of those, we can figure out all this stuff down here, but we got to get something over here. So let's look at our next rule. The total current, or amps, is equal to the sum of the currents through all of the circuit branches. And we know that we can figure out the current through this branch because we got 2 of these. So let's do that. We know we have ohms and volts. So here's amps right here. Volts divided by resistance. Volts divided by ohms. So we're going to go ahead and do that. So volts divided by ohms at all 3 of these spaces will give us our amperage. And then we can add, if we look at our rule again, we can add that amperage up at each one of those spots and get our total. So volts divided by, 9 divided by 90. And you're going to get, oops, I got to turn that on, don't I? 9 divided by 90, you're going to get 0.1. So we have 0.1 amps right there. 49 divided by 45. Should get 0.2 because 45 is half of 90. 0.2 amps. And 180 is double that, so you're going to get 0.0. So 9 divided by 80, 0.05 amps. Now, let's look at our rule again just to double check. The total current is equal to the sum of the currents through all the branches. We just add these together, 0.35. Okay, so now I just use I have at least 2 variables everywhere. If we know volts and amps, how do we find resistance? Volts divided by amps gives us resistance. So volts divided by amps. 9 divided by 0.35. So our resistance, our total resistance is 25, and we round to 3 places after the decimal. So 7 makes that a 6, makes that a 9, makes that a 3. So 25.714. 25.714 ohms is our total, which brings us to our last rule. The total resistance of a parallel circuit is always less than the resistance of the lowest value resistor or branch in the circuit. So it's counterintuitive. Our total is going to be less than the lowest of the other ones. So our lowest is 45 ohms on resistor 2. Is 25.714 less than 45? Yes, so it follows rule 3. Okay, so then the only thing we got left here is power on all of these. And if we look at our wheel, remember when you know all 3 values and you're looking for the 4th, you can use any one of these and it will work. Choose the easiest one. Volts times amps gives us power. So we're going to do that for all of them. On our total, 9 times 0.35, 3.15. That is the total amount of watts that this circuit will produce. 9 times 0.1, 0.9. For resistor 1, 9 times 0.2, 1.8. For resistor 2, 9 times 0.05, 0.45. Now, these should add up to that. So let's go ahead and just check our work. 0.9 plus 1.8 plus 0.45, 3.15. It adds up. So that's how you do a parallel circuit. When it's set up like this, pretty straightforward, right? So this you put under the parallel circuit explanation in the spreadsheet, and I'm going to post another one that I want you to do that is going to be the parallel circuit practice, and then I'm going to have a video where all I do is show you the answers. I'm not going to walk you through and teach you another lesson. I'm just going to do the calculations in front of you, and you can check your work on the practice one. So put both of them in that spreadsheet, please. All right, guys.